So when we did the law of sines, you had to have opposites. Okay, you had to know opposites. Okay, so you had to have C and C, A and A, B and B. You had to have one set that you knew plus one other thing. Okay, so for law of sines, you had to have angle, angle, side, or angle, side, angle, or side, angle, or side, side, angle. That's the ambiguous case where we had the last time, which was yesterday, where we knew two sides and then an angle, so then we could have 0, 1, or 2 triangles. Okay, so if you knew that amount of stuff, then you use law of sines. Law of cosines. Law of cosines, when we have, and I should have done alpha, beta, gamma, not ABC, but it's all right. You guys are smart enough to figure things out. When you do law of cosines, that's when we have the situation of side, angle, side, or side, side, side. Because if you have side, angle, side, these three things, side, angle, side, you don't have the opposite of B, you don't have the opposite of C, and you don't have the opposite of A. So you cannot do the law of sines. We'd rather do the law of sines because it's shorter and quicker. If you have side, 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 you don't have any angles opposite, you can't do law of sines. Okay? So, law of cosines is this, and there's three of them. A squared equals B squared plus C squared minus 2BC cosine of alpha. Or else B squared equals A squared plus C squared minus 2AC cosine of beta. Or C squared equals A squared plus B squared minus 2AB cosine of gamma. Those are our three law of cosines. Okay, let's look at the pattern going on here. Because once you figure out one, then you can figure them all out really easy. If there's an A here, your other two sides are B and C. So if A squared is here, then it's B squared C squared minus 2 times these two letters, cosine of this letter here. Okay? And notice how that pattern repeats. If a B is here, then it's an A and C and an A and C, and B matches B. And if a C is here, A and B, C matches C. Okay? So, law of cosines, we can easily find an opposite side if we're given SAS, or it's a little work to find an angle when it's side, side, side given to us. So let's take an example. So we have a triangle. Let's make this 15, this 17, and this angle 56 degrees. And we want to find the rest of the angles and sides. Okay? So if this is alpha and beta and gamma, Then I want to find side A. I did count you absent, so were you in the? Did you check through the office? Or, oh, you were given blood. Okay. So I will have to figure. I'll get you squared away with the office. Okay. So if I want to figure out A, then I'm going to use the top one of these. A squared equals B squared, which is 17 squared, plus C squared, 15 squared, minus 2 times 17 times 15 cosine of 56 degrees. Oh, you've got to be kidding me. My calculator won't come up. Yeah, I won't worry about my calculator right now. Okay, so what you can do is put this straight into your calculator. 17 squared plus 15 squared minus 2 times 15 times 17 cosine of 56, all straight in there. And A squared will equal some number, I would guess, around 250-ish. I don't know, though. I could be way off.
Yeah,
220.8?
228.8.
228.8. Now, is this side going to be 228.8? No, because that's what A squared is. If we take the square root of each side, then we figure out what A is. So A must be 15.1-ish.
Yeah.
Okay, A is 15.1. Now, how do we find our angles? Well, instead of using law of cosines, we can use law of sines to figure out our angle. Now, if this is 15.1, I would figure out my smallest angle first. Don't figure out your biggest one, figure out your smallest one. Because in law of sines, what do we know about two different sines? They can be two different angles, right? So if you have an angle that's like, 87 degrees, it could also be 93 degrees, okay? And things don't always work out. So find your smallest angle first. So we want to find gamma first. So I'll say the sine of gamma over its opposite side, 15, equals the sine of 56 over its opposite side, 15.1. Now, you might have some rounding errors, and so sometimes they'll ask you to list the first 4 decimals of this so you don't have a rounding error. But we're just going to go with 1 decimal for now for our practice here. So take 15 times the sine of 56 divided by 15.1. What do we get? Sine of y equals 0.0. Give me 4 decimal places. 8235. Okay. So that's what the sine of y is. We need to figure out what the angle is. So we move the sign to the other side, so it's second sine, second answer, because it's the inverse sign of that decimal. So second sine, second answer. What is that angle going to be? 55.4. This is a 55.4 degree angle. And then angle B is what, or beta is whatever we get when we subtract 180 from it. So 180 minus 56 minus 55.4. 68.6. Okay? Law of cosines. So when we have a side angle side situation, we can figure that out. Now, I don't think we have any side ones on today's homework. So wait for the side till Tuesday. Okay? But let's do one more of these. Let's say this one is 37, 21, and 16. 37, 21, and 16. Okay. So if this is alpha, beta, and gamma, which law of sines would I use? The first one, the second one, or which law of cosines would I use? The first one, second one, and third one? Second one. Because if I'm given angle beta, then I'm going to use the one where b is alone. B squared, because b is what I'm looking for, equals a squared plus c squared minus 2ac cosine of beta. So b squared equals a squared, which is 16 squared, plus c squared, which is 21 squared, minus 2 times 16 times 21, cosine of 37. What's b squared equal? 160.3. 160.3. Take the square root of that. I bet we're about 40. No. Something doesn't look right. It must be 4. Yeah, a bit over 12. I was thinking 1600, not 160. Sorry. So it's 12.7. That makes more sense. So 12.7. So now to figure out angle alpha, what would I use? Law of sines. Sine of alpha over 16 equals the sine of 37 over 12.7. So this times this divided by this. 16 times sine of 37 equals, divided by 12.7 equals, and do second sine, second answer. What's our angle? 49.3. So, if you take 37 plus 49.3, that's like 86.3, right? So what's left for this angle is 93.7. If you did law of sines and found angle gamma first, you would have probably gotten 86.3. Okay, you would have probably gotten 86.3 if you would have done law of sines, which would have been the wrong answer. That's why we need to find the smaller one first. Okay, because the sine of 93.7 and the sine of 86.3 are the same number. Okay, so don't go down the wrong road. Find the smaller of these two first. Okay, so we got every side and every angle, and that's what we're after. So you will have an assignment which will be on Math Excel, which is 5.2a, which is the beginnings of the law of cosines. And then you'll have some law of sines in there too. And then Tuesday, we'll get going with the solving for angles in the law of cosines. So let me get this out there for you. Don't fall.
Okay, before anyone else, Julie told me to ask you for help on the second question of the problem last time, and I'll understand everything. So, just give me a quick little run through after you post it.
All right, it's posted.
Anybody else.
All right. So
Are you in a good mood today?
I think so. Yep. Hey, I was counting 8 and 4 on absent, but she was getting blood. Yeah, you put it other, so yeah. But okay, she was here now, so okay, bye. No. Let me guess, you don't have a computer yet. What?
That's why we do.
Oh. Hold on. Hold on. Yeah, we gotta get you in the class and Excel and all that stuff.
So.
Right now, I'm not doing nothing.
Oh, they're right there.
The bigger one. No, I can just.